Okay, so for our first example, a 24-pound weight stretches a string 4 inches and it starts out 3 inches above equilibrium at rest. What is the equation of motion? So the first thing we have to ask ourselves about this problem is what is the information that is actually given, okay? Well, the first thing, let's look at Hooke's law. So we have 24 pounds and it stretches the string 4 inches. All right, now this needs to be pounds per feet, okay? So if it's stretching at 4 inches, what is 4 inches? Well, there's 12 inches per foot. So we'd have to say, well, that's 4 divided by 12, so that's a third of a foot, okay? So 24 is going to equal K, now multiplied by 1/3 foot, because it's 4 inches, okay? Okay, so what is that telling us? That's telling us that K is going to equal now 72 pounds per foot. All right. Okay, so we have K is going to equal 72. Then we have to have M, okay? Now, what is the mass of this thing? So whenever you do this, you know, force equals mass times acceleration. So mass would equal force divided by the acceleration. So the force would be the weight. And what is your acceleration? The acceleration is gravity. So the mass is actually going to be now 24 divided by 32, which equals, that's 3/4. Okay? So you always have to divide the weight by the force of gravity. Okay. So what other bits of information are we just given inside of the problem? Okay. So let's look at the information that we're given. Okay. So the information for Hooke's law that we're given is that the 24-pound mass stretches at a third of a foot. Now, it's going to start out at 3 inches above equilibrium, okay? So this also needs to be in feet. So what is 3 inches? That's really a quarter of a foot, okay? It's 1/4 of a foot. So 3 inches, what does that mean? It is above equilibrium. Remember in the previous video, I said that if it is above equilibrium, its x is less than 0. If it's below equilibrium, x is greater than 0 because it's stretched out farther. So that's telling me that at 3 inches is where it's going to start out. And so that means that x of 0 is going to be -1 divided by 4. Sorry, here we are. So it's above equilibrium, and it's 3 inches above equilibrium, so it's -1/4 of a foot above equilibrium, okay? So, and then what is the other statement that it says? This one's actually kind of hidden in there. So it says, all right, it starts out at 3 inches above equilibrium at rest, okay? What does that mean that it is at rest? Is that you held that thing 3 inches above equilibrium and you let it go. You didn't give it initial velocity or anything. You just hold it there and just let go and let the string do its own business. So what is that telling us about this? That's saying that x prime of 0 is going to be 0 to starting out at rest. So this is all the information that we need to start forming this problem. All right. So remember that this was. Okay, so m, the second derivative of x with respect to time, plus kx, which is going to equal 0. All right, so m was 3 divided by 4. Now the second derivative of x with respect to t. And then plus 72x, which is going to equal 0. Okay? Now I can multiply by the 4/3. So the second derivative of x with respect to time, this is going to be 96x. which is going to equal 0. Okay? So, if we were going to solve the auxiliary equation for this is not going to be mass. We'll call this, and normally we use M for the auxiliary equation. Let's use a different letter for the auxiliary equation. Let's say L. Why not? So, okay. So that would be the auxiliary equation. All right. So L will equal plus or minus I and 4 root 6. I already wrote all these numbers down, so I don't have to go to my head. Okay. All right. So all we have is the complex part. We don't have a real part to this problem. So x is going to equal C1, now cosine of 4 root 6x plus C2, now sine All right. So now we're going to use our initial conditions for the problem. So x of 0, Larry said this is negative 1 divided by 4. Right? So negative 1 divided by 4. All right, so cosine of 0 is 1, and sine of 0 is 0. So this would be C1 cosine of 0 plus C2, now sine of 0. Okay? So what that's telling me is that C1 is going to equal negative 1 divided by 4. Okay? All right, now let's go to the next derivative. I mean the first derivative. The next initial condition. So let's say, okay, so for my other initial condition, I have that x prime of 0 equals 0. Okay? So that's going to give me that 0 is going to equal, right, derivative cosine is negative sine, so this would be negative C1 sine of 0 times 4 root 6. And the derivative of sine is cosine plus C2. Now cosine of 0, 4 root 6. Okay? So, from this problem, sine of 0 is just 0, but cosine of 0 is 1. So that's telling me that C2 is actually 0. Right. So what that's telling me is that x of t is going to be negative 1 divided by 4 times cosine of 4 root 6 t. Oh, excuse me, these should be t's. Because it's going to be a function of time.